Yes. Good morning, students. Welcome to the lecture 33 of fluid mechanics subject. So we are in Unit 3 discussing about laminar flows and turbulent flows. So in the last class, we have discussed about the importance of turbulent flow in the pipes. We have discussed about turbulent flows in the pipe. So now in this class, we will see about the various friction losses in the pipe flow as laminar or turbulent, right? So here in this laminar flow or turbulent flow, whenever the fluid is flowing in a pipe, so we are seeing how the friction losses develop in the pipe. Whenever the flow is having high discharge and low discharge, right? So in this class, we'll discuss about the friction losses and also the pipe. Yes. So as usual, oil and gas refinery. Yes. So now we will discuss the friction loss in the pipe flow. How the friction loss takes place in the pipe flow whenever you are using laminar flow as well as turbulent flow, right? Uh, so yesterday also very few students were attended the class. So hope I'm asking to join the class through WhatsApp. Okay. So here we will discuss about the friction loss in the pipe flow. So whenever we are using the turbulent flow, we will see what happens whenever the turbulent flow is operating in the friction losses, right? So when a liquid is flowing through a pipe, so when a liquid, whatever the liquid you are using, so whenever the liquid is flowing through a pipe, the velocity of a liquid layer, adjacent to the pipe wall. So for example, whenever you are having a pipe of circular cross section, right? So whenever the pipe is flowing at this junctions, whenever the pipe is flowing at this junctions, what happens? The pipe wall is zero, right? The velocity of liquid layer adjacent to the pipe wall is zero. Means whenever the water is flowing in this direction, whenever the water is flowing in middle of the pipe, or some other places of the pipe, so the velocity will be at some velocity. Whenever whenever the liquid layer is touching at the adjacent of the pipe layer, the velocity is zero, right? Then the velocity of liquid goes on increasing from the wall, and thus velocity gradient and hence shear stress are produced in the whole liquid due to viscosity. So what happens whenever the liquid layer is touching the adjacent layers of the wall, the velocity is zero, right? Whenever the velocity of liquid goes on increasing, when it goes on increasing from the wall towards the center, and thus the velocity gradient and hence the shear stress also developed in the whole liquid due to viscosity. So thereby the viscous nature of the liquid, so the shear stress and also the velocity also keep on increasing. This viscous action causes losses. This viscous action causes loss of energy, which is usually known as friction loss. So what happens whenever the velocity is zero at the layer at the adjacent walls of the pipe, whenever it is keep on increasing towards the center, the velocity gradient and the stresses are also increasing. So whenever the viscous action increases, there what happens, viscous action ఎప్పుడైతే మనకి ఇంక్రీజ్ అవుతూ ఉందో ఫ్రిక్షన్ లాస్ అనేది మనకి జరుగుతుంది, రైట్? This causes loss of friction losses. Then on the basis of these experiments, the scientist William Froude gave some of the laws of fluid fraction for the turbulent flow. So whenever in case we are using a turbulent flow, so turbulent flow ni manam teeskunte friction laws lo, the William Froude has given some laws of fluid friction. From laws of fluid friction, the laws of the frictional resistance of turbulent flow is proportional to the V to the power of n, where n is 1.5 to 2, where n ranges from 1.5 to 2, right? Next, second one, proportional to the density of the fluid. So we have to see the properties of the fluid also. What is the density of the fluid? So it is proportional to the density of the fluid. Next, third one, proportional to the area of surface in contact. So we have to see the frictional resistance is proportional to the area of surface contact. So how much area of pipe you are having, and how much the fluid is how much fluid is in contact with the surface area of the pipe. Next, it is independent of the pressure. So the friction is independent of the pressure, how much it is acting. Next, it is dependent on the nature of the surface in contact. So what type of nature of surface is there in contact with the pipe? It is a slippery, or a sticky, or maybe a rigid. So that depends upon the nature of surface in contact. So these are the some of the laws proposed by William Froude. So whenever you are taking in the turbulent flow in action, right? Next, then whenever you are taking an expression with an expression for loss of head loss HL due to the friction వల్ల head loss వస్తే pipes లో ఎలా ఉంటుంది. So we will discuss with this derivation. Consider a uniform horizontal pipe having a steady flow shown in the figure. So take a pipe of uniform cross length, diameter is same, uniform length. Make it as, let section 1 and section 2, we are making a sections. Entry section and exit sections. Let at 1 and 2 are the two sections of the pipe. Therefore the fluid is flowing from this end, the fluid is coming this end. So the pressure of this one is P1, the pressure is opposite this one is P2. Here the force is a F1 acting. Then if you take the particle, if you take the space between 1 and 2, now see here, let P1 is a pressure intensity at section 1. Let P1 is a pressure intensity at section 1. Net V1 is a velocity. V1 is a velocity at V section 1. V1 is a velocity at section 1. Next, L is a length. L is the total length of the pipe between section 1 and 2. So this one is a L. So here to here, this one is a L length of the pipe. Next, D, small d is the diameter of the pipe. Small d is the diameter of the pipe. Next, F dash is the frictional resistance per unit wetted area per unit velocity. So per unit wetted area means whatever the water is flowing inside the pipe, it is nothing but a wetted area per unit velocity. Then HF is a loss of friction, loss of head due to the friction. So HF. So కొన్ని books lo you can write HL also, right? HF is loss of head due to the friction. Next, P2. P2 is a pressure intensity at section 2, and V2 is a velocity at section 2. The values of pressure intensity at section 2. So section 1 ki section 2 ki manamu inputs raskunnam, right? By taking this one, applying the Bernoullis equation for section 1 and 2, applying the Bernoullis equation between section 1 and section 2. Therefore, what happens? The total head at section 1 is equal to total head at section 2 plus head loss. Okay, so what is the Bernoullis equation? Pressure energy plus kinetic energy plus gradient line, right? Datum line or gradient line. So pressure energy plus kinetic energy plus datum line is equals to section 2 lo pressure energy plus kinetic energy plus gradient line plus head loss. Okay na? So like this, whenever you are applying, total head at 1 is equals to total head at 2 plus head loss at 1 and 2. So appudu ela rastunam? So P1 by rho g plus V1 square by 2g plus Z1 P2 by rho g plus V2 square by 2g plus Z2 plus head loss HF, right? So here the pipe మనకి horizontal గా ఉంది కాబట్టి gradient line మనకి same. So whenever the pipe is slanting మనకి ఇలా ఉంది అనుకుందాం, ఇది మనకి సర్ఫేస్ అనుకుంటే whenever the pipe is like this ఇలా ఉన్నప్పుడు then automatically మనకి gradient line అనేది you are making some angle, so మనకి ఇక్కడ horizontal ఉంది కాబట్టి there is no problem of Z1 and Z2. Therefore Z1 and Z2 are equal. Therefore V1 and V2 are also same. Why? Because the diameter of the pipe is same, right? Therefore Z1 is equal to Z2 as a pipe is horizontal, and V1 is equal to V2 as the diameter of the pipe is same at 1 1 and 2 2. Therefore how to write this equation? This equation can be written as P1 by rho g is equals to P2 by rho g. So ఇది మనకు ఉండదు V1 V2 same, Z1 Z2 same, plus HF, or HF అని ఎలా రాస్తున్నాం, head loss is equals to P1 by rho g minus P2 by rho g. So but HF is head lost due to the friction, and hence the intensity of pressure will be reduced in the direction of the flow by frictional resistance. So దీన్ని మనం consider one as, right? Now frictional resistance is equals to frictional resistance per unit wetted area into velocity square. Then how to write this equation? Therefore F1 is equals to F dash into pi dl into v square. Therefore what is wetted area? Wetted area is equals to circular pipe kabatti pi d into length, velocity is equals to v1 or v2 is equals to v. Why? Because the diameter is same kabatti velocity will be same. How to write this one? F1 is equals to F dash into pi dl is equals to pi d is equals to p into l into v square. So what is pi d here? The perimeter p. So దీన్ని ఎలా కన్వర్ట్ చేస్తున్నాం? F dash is equals to F dash into p into l into v square. The force acting on the fluid, sections 1 1 and section 2 2. The forces acting on the fluid section 1 1 and 2 2 are then at section 1 the pressure at section 1 1 is rho p1 into a, where a is the area of pipe. Section 2 is also same, P2 into A, where area is a area of pipe. Next, frictional force F1 as shown in the figure. Right? Next, resolving all the forces in horizontal, we have F at section 1 1 minus section sec 2 minus F1 is equals to 0. So P1 pressure 1 into A minus pressure 2 into A minus friction loss, this one. Now the friction resistance is equals to 0. Next, then as you know, so is equals to 0. Therefore making common this one, P1 minus P2 into area is equals to F1. What is F1 here? F1 F1 is equals to friction into pressure into perimeter into length into v square. So ikkada nunchi manam teeskunnam kabatti, so this one can be F1 can be written as like this. Therefore P1 minus P2 is equals to total of F dash into P into L v square by A. This one is a A. So therefore, but for the equation P1 is equals to P2, that is rho g hf head loss, how we are writing this one? Equating the value of P1 minus P2. So E place of one we substitute chestam kabatti rho into G into HF is equals to F dash into P into L into V square by A. Therefore HF head loss is equals to F dash by rho G into P by A into L into V square. Therefore from the equation 3, P by A is equals to, what is the P here? Is a perimeter, A is the area. Therefore perimeter is pi d, area is equal to pi d square by 4. Therefore cancelling this one and this one, we are getting 4 by d. Now HF is equals to F dash by rho G into, apply this one, P by A is equals to 4 by d. So దీన్ని ఇక్కడ apply చేస్తే same L into V square వేస్తే, then after simplifying this one we are getting F dash by rho G into 4 LV square We are getting 4lv square divided by d, right? Now putting this one f dash by p is equals to f by 2, where f is a coefficient of friction, right? Then by equating this fourth equation, we are getting hf is equals to 4 into f by 2g into lv square by d. Okay, so దీన్ని మనం ఎలా చేస్తున్నాం, 4f lv square by d into 2g. Now the equation 10.2 is known as Darcy-Washback equation. So మనం ఏ ఈక్వేషన్ కనుక్కున్నాం, with this friction loss by using the Bernoullis equation we have derived Darcy-Washback equation. So whenever you get a question, derive the Washback equation of a horizontal flow అన్నప్పుడు మీరు ఈ ప్రాసెస్, ఈ డెరివేషన్ చేయాలి. This equation is commonly used to find out the loss of heads in the friction in pipes. So where this Darcy-Washback equation is used, this is used for finding the loss of head due to the friction in the pipes. Keep in mind that Darcy-Washback equation is used to find out the loss of head due to the friction in the pipes. Sometimes this equation can be written as, simplify చేసి రాయొచ్చు, hf is equals to lf into l into v square into divided by 2 into d into 2g, right? So this f is known as friction factor. F is a friction factor. So understood? So this equation is a Washback equation, what we have derived through the Bernoullis equation. Understood? So how we are derived the expression for the hf ఎలా కలుపుకున్నాం, hf is equals to, so you have to keep this formula in mind. hf is equals to 4 into f into l into v square divided by 2 into d into 2g. లేదంటే we can keep this one in the mind. hf is equals to f into lv square divided by 2d into 2g, right? So this is Darcy-Washback equation. Next, hope you understood this one. Next one is how to derive the expression for coefficient of friction in terms of shear stress. So based upon the Washback equation, how you are deriving the coefficient of friction by using this one. The equation 10.1 gives the forces acting on a fluid between section 1 and 2. Section 10.3 of the horizontal direction as, so మన Washback equation లో coefficient of friction కనుక్కోవడానికి shear stress, we are taking this equation P1A1 P1A minus P2A minus F1 is equals to 0 అని తీసుకొని, సో ఇది ఎక్కడ ఉంది, it is derived from the this one Washback equation only, this one, right? This equation we are using here. మనకి ఇది ఎగ్జామ్ లో రాదు, but for getting the formulas we are deriving this one, expression for coefficient of friction. So P1 minus P2 common, A is equals to F1, where force due to the shear stress tau 0, that is equals to shear stress into surface area. What is shear stress here? Shear stress is tau 0 into surface area, pi d into L. Why? Because it is a circular one, pi d into L, surface area. Or how we can write this one, P1 minus P2 area, ఈ ఏరియాని ఎలా రాస్తున్నాము, pi by 4t square is equals to tau 0 into pi d into L, where A is equals to pi by 4d square. సో ఇది మనము అప్లై చేస్తాం, ఓకేనా? నెక్స్ట్, now consider cancelling pi d from the both sides. So after getting this one, cancelling this pi d and pi d here and here, how you are getting this one, P1 minus P2 into d by 4 is equals to tau 0 into L. Therefore P1 minus P2 is equals to 4 tau 0 into L divided by d. Okay na? Next, how this equation 10.2 can be written as equation, this equation 10.2 మనకి దీని వచ్చింది కదా, this Washback equation. How this can be written with respect to shear stress? hf is equals to P1 minus P2 by rho g. Therefore, what is P1 minus P2? Write this one. 4 into F L V square divided by D into 2G, right? D into 2G. Then how this can be modified? P1 minus P2 is equals to 4 into F into L into V square by 2 into 2G into rho into G. So rho into G equal to this one. This rho into G. Okay. Now, equating the value P1 minus P2 in the equations 10.3 and 10.4, how we are getting the equation P1 minus P2? ముందు మనం ఏం తీసుకున్నాం? P1 minus P2 is this one. ఇది తీసుకున్నాం కదా? So take this one and substitute here. 4 tau 0 into L divided by D is equals to same 4 into F into L into V square divided by 2 into 2G into D, 2G into D into rho G. Therefore, stress ni బయటికి తీసుకొచ్చేసండి. Tau 0 is equals to F V square into rho G divided by 2G is equals to F V square by 2G into rho G, right? Then Tau 0 is equals to F into rho V square by 2. So ఇక్కడ మనకి GG cancel చేసేస్తే, so GG cancel చేసినప్పుడు we are getting tau is equals to F into rho V square by 2. Therefore, frictional factor F is equals to 2 into tau 0 divided by rho into V square, right? This is a equation. This is the equation for the expression for coefficient of friction in terms of shear stress. So మనకి problems లో ఎప్పుడైనా shear stress problems వచ్చినప్పుడు we can use this formula for horizontal pipe flow, right? Understood? So this is for the coefficient of friction, that is for friction factor. So whenever the coefficient of friction with respect to shear stress ఉన్నప్పుడు we can use this type of equation. Next, shear stresses in turbulent flow. How the shear stresses are formed in the turbulent flow. Next, the shear stress in the viscous flow. The shear stress in the viscous flow is given by the Newton's laws of viscosity. Stress in the viscous flow, tau V is equals to mu into du by dy, where tau V is equals to shear stress due to the viscosity. Therefore, the mathematical formula can be written as, for this turbulent flow, tau T is equals to viscosity into dou u by dy. Therefore, tau D is equals to shear stress due to the turbulence. Shear stress due to the turbulence is equal to eddy viscosity, and mu bar is equals to average viscous velocity at the distance y from the boundary, right? So the ratio of this one is nothing but eddy viscosity. This efficiency is given nothing but eddy viscosity, and this rho is mass density, is known as kinetic eddy viscosity, and is denoted by epsilon. So this can be denoted eddy viscosity denoted by epsilon. Mathematically, it can be written as epsilon is equals to the ratio of eddy viscosity by mass density, right? So epsilon is equals to this eddy viscosity divided by mass density. Next one. If the shear stress due to the viscosity flow is also considered, if the shear stress due to the viscous flow is also considered, then the total shear stress can be written as total shear stress tau is equals to viscous shear stress in the viscosity plus shear stress in the turbulence, that is equals to tau is equals to tau v plus tau t. Okay, that implies u dou u by dou y plus eddy viscosity into dou u dash by dou u dy. So this is MK0. What? This is a total shear stress. That the value of mu n is equals to 0 for laminar flow. For laminar flow, the eddy viscosity is 0. For other cases, the value of eddy viscosity may be several thousand times the value of mu. To find the shear stresses in the turbulent flow, equation 10.7, this equation, right? This equation 10.7 gives by the Bernoulli is used, given by Bernoulli is used. But As the value of the eddy viscosity cannot be predicted, this equation is having a limited usage. So therefore, whenever you are getting the shear stresses and shear stresses for both viscous and as well as turbulent flow, write this total velocity, total shear stress tau is equals to tau v plus tau t. That is equals to this one. Okay. Next. So in this unit, we have completed the 3 derivations. First one is with the, so students are joining now. So majority of students have joined just a few minutes back. Only Falguna starting Chunada. Snehalata. Okay, no issues. So here we have discussed in the whole session, we have discussed 3 derivations. First derivation is the friction loss. Second derivation is the coefficient of friction. Third one is the shear stresses in the turbulent flows. So just to make oksari, so students andaru ippudu vacharu. So just make fast ga meeku oka approach chupistanu. So here the friction loss in the pipe flow. In this session we have completed 3 derivations. First is friction losses in the pipe flow. So by taking the assumptions, by taking the laws of William Ford, so manamu ee friction loss manamu accept chesam. By taking this one into consideration, so we are deriving which equation? We are deriving Washback equation. We are deriving the Washback equation. This one, that's the Washback equation. So ee equation ni manamu ee vidhanga by taking a horizontal pipe, right? So in order to get the expression for head loss due to the friction in the pipes, we have derived the Darcy-Washback equation. So Darcy-Washback equation is used for deriving the loss of head due to the friction in the pipes. So if you get a question in the exam, derive the Darcy-Washback equation for the friction in the pipes అన్నప్పుడు మీరు ఈ ఎక్స్ప్రెషన్ రాయాలి, ఈ డెరివేషన్ రాయాలి, ఇక్కడ నుంచి టోటల్ గా రాయాలి. So what we have chosen here, we took a horizontal pipe of uniform cross section. Therefore velocity is same ఉంటుంది, area కూడా same ఉంటుంది, but pressure will be different. So here taking at section 1 P1 V1, right, at section 2 P2 V2. Therefore L is the length of the pipe and D is the diameter of the pipe. F dash is a frictional resistance per unit per wetted area. HF is a loss of head. Next, so applying the Bernoullis equation. So ఎవరైతే రీసెంట్ గా జాయిన్ అయ్యారో 3-4 మెంబర్స్ వాళ్ళకి ఫాస్ట్ గా చెప్తున్నాను. So applying the Bernoullis equation, we know the Bernoullis equation is pressure energy plus kinetic energy plus datum energy is equals to pressure energy plus kinetic energy plus datum energy at section 2-2. Formula concept తీసుకొని applying here, so we get this one plus head loss. So here మనకి horizontal గా పైప్ ఉంది కాబట్టి Z1 is equal to Z2. So ఈ రెండు మనకి యూస్ లేదు. Then V1 is equal to V2. Why? The diameter is same, area is same కాబట్టి దీన్ని కూడా మనము we are taking this common. Therefore balance ఏమున్నాయి, P1 by rho g is equals to P2 by rho g plus HF. So therefore HF ని ఎలా రాస్తున్నామంటే ఈ విధంగా రాస్తున్నాం, right? So of writing this one, so taking the friction into account, F1 is equals to F into pi dl into V square. So we are treating this as like this. P is equals to perimeter pi d, right? So after processing this one, we got the forces acting on the fluid between section 1 and 2. So by taking this 3 into consideration, resolving all these factors, P1A minus P2A minus F1 is equal to 0. ఈ F1 place లో ఇది ఈ వాల్యూ సబ్స్టిట్యూట్ చేస్తే, therefore P1 minus P2 into A is equals to F dash into P into LV square. We are getting P1 minus P2 is equals to this one, right? So but we know that P1 minus P2 is rho into G into head loss. So దీన్ని మనం ఎలా రాస్తున్నాం, that is equals to, so ఈ equation మనం రాస్తున్నాం. So finally what we have to get the friction head loss. Therefore friction head loss ni, so taking in the left hand side, HF is equals to F dash by rho G into P by A into L into V square. So in this equation P by A అంటే మనకి perimeter by area. So how we are writing this one, pi d divided by pi d square by 4. So దీన్ని మనము simplify చేస్తే we are getting 4 by d. So applying in this equation, HF is equals to F dash divided by rho G into 4 by D into L into V square. So the ఇంకా further simplify చేస్తే we are getting this one, right? Next. So finally HF is equals to 4 into F LV square divided by D into 2G, D into 2G, which is nothing but Darcy-Washback equation. So we have derived Darcy-Washback equation, right? Next. So the next derivation is expression for coefficient of friction in terms of shear stress. So మనం next expression ఏం చేస్తాము, we are finding the coefficient of friction in terms of shear stress, So taking the equation, this one in the Washback equation now, we have to take this one, P1A minus P2A minus F1 is equal to 0. Okay, so taking common A is equals to F1. So here F1 is equals to force due to the shear stress. Therefore, shear stress into surface area. Then what is shear stress? Shear stress is tau 0 into surface area is pi d into length of the pipe. Pi d into length of the pipe. So substituting here P1 minus P2. So applying this area, pi d square by 4 is equals to tau 0 into pi d into L. Pi d into L. Cancelling the pi d on both sides, we are getting the equation as P1 minus P2 d by 4 is equals to tau 0 into L. Therefore, P1 minus P2 is equals to 4 tau 0 into L by D. Okay, this equation can be written as HF is equals to 4 into F into L V square by D into 2G. So then further simplify cheste, equating the value of P1 minus P2. Therefore, P1 minus P2 value can substitute cheyandi. E value as it is, keep here. Therefore, manaku final gain kavali, we have to get the shear stress. That's why we are separating and writing shear stress in turbulent flow tau 0 is equals to FV square into rho G divided by 2G. So దీన్ని మీరు ఫర్దర్ ఇలా సింప్లిఫై చేస్తే, తర్వాత దీన్ని GG క్యాన్సిల్ చేస్తే, so tau 0 is equals to F into rho V square by 2. So therefore F is equals to this one. So finally what we got the shear stress equation. This is the shear stress equation. This is the friction factor equation. So like this we have got the shear stress in the turbulent flow, right? Next, the coefficient of friction in the turbulent flow. Now whenever you are applying the shear stress for both laminar flow and turbulent flow, in just now the total stress we are applying, then what is the total stress here? Tau is equals to shear stress, viscous flow shear stress plus turbulent flow shear stress. So we are taking both into consideration whenever you are taking the total shear stress, right? So the shear stress in the viscous flow is given by Newton's laws of viscosity. So Newton's laws of viscosity. So generally we are writing as tau is equals to mu into du by dy, right? Where tau is equals to shear stress due to the viscosity. Then by writing for the turbulent flow stress is equals to n into du dash by dy, where this one is equals to shear stress due to turbulence, efficiency is equals to eddy viscosity, and mu bar is equals to average velocity at the distance y from the boundary. Therefore taking the ratio of eddy viscosity and mass density, it can be denoted as epsilon, nothing but kinematic eddy viscosity. Therefore kinematic eddy viscosity is equals to eddy viscosity divided by mass density. So this can be written as epsilon. This e ni manam em cheptunam, epsilon ani manam we are giving the name. Epsilon is equals to eddy viscosity divided by mass density. Next, if the shear stress due to the viscous flow is considered, then what happens? You have to take the total shear stress into consideration. So shear stress due to the shear flow consider chestunnappudu, we have to take total shear stress into consideration. Therefore, total shear stress is equals to viscous shear stress plus turbulent shear stress. That is equals to tau is equals to tau v plus tau t. That implies mu of du by dy plus d viscosity into d mu bar by dy. Therefore, eddy viscosity is 0 for laminar flow and eddy viscosity is high for other value, that is the turbulent flow. This equation is limited only for some usage only, right? When you get a question of finding the values for total shear stress, you have to apply this one and you have to write the answer, right? So with this, we have completed the 3 derivations by using Bernoullis equation. So in this session, we have learned about Darcy-Washback equation and the coefficient of friction F and the forces in turbulent flow. What type of forces? Shear forces in turbulent flow, right? So when you get a question, so meeku e topic, e PPT, e lecture lo, you get a question in the exam like derive the expression of Darcy-Washback equation in uniform horizontal pipe ani direct ga vastundi, or else derive the expression for loss of head due to the friction in the horizontal pipe annappudu we have to start with Darcy-Washback equation. So intavaraku, so very direct and a small derivation, that is Darcy-Washback equation. So intavaraku meer solve cheste, that is the solution you are getting for the answer, right? This is Darcy-Washback equation. ముందు దాంట్లో మనము అదర్ ఈక్వేషన్ గురించి చెప్పుకున్నాం లాస్ట్ ప్రీవియస్ క్లాసెస్, దట్ ఈస్ Hagen-Poiseuille's equation. Hagen-Poiseuille's equation, that is for laminar flow, this is for turbulent flow. Okay na? Right. So in this laminar flow you are getting about the Hagen-Poiseuille equation, and the turbulent flow you are getting Darcy-Washback equation. So you have learned 2 equations for this laminar flow and turbulent flow. One is Darcy-Washback equation for turbulent flow and Hagen-Poiseuille equation for the laminar flow. So third unit lo, these 2 equations are very, very important. So in the next session we will see about the losses in the pipes. So friction losses gurinchi manam cheppukunnam ippadi varaku. In the next class we will see about the flow between parallel plates and the flow through long tubes. So short tubes flow, the expression will be different. The pressure, velocities and the capacities will be different when compared to the long tubes, and also hydrodynamically smooth and rough flows in the turbulent flows, right? And also we'll see the minor losses in the pipes and what is about the hydraulic gradient line and total gradient line, and also the various other derivations used by the hot cross method and Hazen-Williams formula and the Moody's chart. Like this, we are having some other derivations derived by set by other scientists for the flow of turbulent flow, right? So with this, we'll stop the session and we'll start the problems tomorrow based upon this equation. Any doubts still here? So majority of students are not coming to the class regularly. Why? So this problematic subjects are some difficult. Why? Because fluid mechanics next semester lo vere పేరుతో change అవుతుంది. So there also will be the same continuity like hydraulic machines. So అక్కడ కూడా మీకు ఈ కొన్ని టచ్ అవుతాయి. So continuation of this fluid mechanics. In 3-1 also will get some sort of things. So that's why I make some basic fundamentals, keep in mind some basic fundamentals and move ahead. So I will send the PPTs for where there are derivations and problems, as well as some soft copy also. Beyond that, you have to keep practice. So why? Because actually, as per Jntuk schedule, 28th నుంచి మీకు మిడ్ వన్ స్టార్ట్ అవ్వాలి, బట్ ఇట్ హాస్ బీన్ పోస్ట్పోన్డ్, రైట్? So we don't know when we get the exams because of this pandemic corona. That's why make sure that practice yourself. సో ఫ్యాకల్టీ చెప్పేంత వరకు, డిపార్ట్మెంట్లో మీకు అనౌన్స్మెంట్ వచ్చేంత వరకు, Jntuk చెప్పేంత వరకు, డోంట్ కీప్ లాగింగ్. వై? బికాస్ వీ డోంట్ నో వెన్ ద date comes, we don't know when the changes comes. So that's why find a time in your daily schedule and practice something related to your topics, right? So because you are at a student age, so practice only the subjects. Other things, that is okay, you are staying in a house working something, but the basic main thing is studying. So practice something, any subject in this course of time. Don't waste your time. Any doubts, you can talk to me. So because the PPT shared is totally completed, we have discussed thoroughly. Any doubts? So this unit can be completed by you next few more 7 to 8 classes. So why? Because we have completed this Darcy Washback equation, where it is a closed horizontal pipe flow. So we have completed this Hagen-Poiseuille flow, right? So we have to start this flow between the parallel plates, flow through the long tubes, hydrodynamically smooth and rough flows. So derivations చెప్పి దీని మీద ప్రాబ్లమ్స్ డిస్కస్ చేయాలి. నెక్స్ట్ pipes in series and pipes in parallel, right? Pipes in series, pipes in parallel, and also a total energy line and gradient line. So these are also should be discussed in this session. So we are having flow through long pipes, close contact. So pipes in series and pipes in parallel. So in this third unit, you will get only very few theoretical questions like explain or what are the characteristics of laminar and turbulent flows, or derive the expression for, or derive the Reynolds experiment equation. You will get that type of question. Or define the laws of fluid friction, or else you will get define hydraulic gradient line and total energy line. Ante define TEL and HGL అని వస్తుంది. So like this, you will get some short questions. Majority of longer questions, part B low, definitely you will get a derivation and a problem. So మొత్తం unit లో you will get a derivation or a problem. The derivation may be Hagen-Poiseuille's equation, or it may be Darcy-Washback equation, right? Or it may be the Hagen-Williams formula. And also the problems comes from Hagen-Poiseuille equation, Washback equation, and the pipes, minor losses in the pipes, and also the Moody chart network problems. So like this, you are getting the derivation plus problem plus a 2 mark question in this from this unit. So I will send the question papers also at some time. So make a note of practicing daily any subject. Make a timetable, practice some subject, so that will be in touch with you. So once this festival is completed, either it may be this Dashara, you may rush towards your exams or a class. We don't know how the dates will come. Okay, right. So we'll stop here. I have your next class in the next 5 minutes. After next few minutes, I have your seniors class. So we'll switch on to the class. So thanks for listening the class patiently, and maintain the attendance in the class also. ఇంకా ఎక్కువ మంది రండి, చెప్పండి, share this information to other students. So thanks for watching this video. Once the video is uploaded in the channel, I will forward this link to your WhatsApp group. Have a look, view it, and share to the other students. Okay, thank you.